On July 6, 1988, the Piper Alpha oil platform in the North Sea experienced a series of devastating explosions and fires, claiming 167 lives out of 226 on board. The platform, originally designed for oil production, had been retrofitted for gas processing, introducing significant safety risks. It took over 3 weeks for the fires to be extinguished. The disaster was the deadliest offshore oil incident in history and caused financial losses of $5 billion. Failures in emergency systems, structural weaknesses, and poor evacuation planning led to the platform's total destruction and long-term environmental impact. The remains of Piper Alpha were toppled into the sea on March 28, 1989. What happened? On the evening of July 6, 1988, condensate pump A was isolated for maintenance on its motor drive coupling. Pump A pressure relief valve had also been removed for maintenance under a separate permit and a blind flange was fitted in its place, but flange was not leak tested or pressure tested. The maintenance crew failed to notify the night shift. At 9:45 p.m., when Pump B tripped, the operators tried unsuccessfully to restart it. The operators would have been aware that Pump A was out of commission for maintenance, but as maintenance had not yet started and the problem with Pump A was not especially serious, and operators would not have known that the pressure relief valve for Pump A was missing. At 9:58 p.m., gas leaked from the blind flange in Module C, which was not properly sealed. The released gas ignited, causing the first explosion. Critical systems, including power, public address systems, and fire pumps, failed almost immediately due to their poor location and lack of redundancy. At 10 p.m., firewalls between modules failed, allowing the fire to spread rapidly to nearby storage tanks and additional equipment. The fire intensified as it reached 1,200 barrels of fuel stored above modules B and C, resulting in a secondary explosion. At 10:20 p.m., a riser carrying gas from the tartan platform ruptured under the heat, creating a massive jet fire that intensified the blaze. Poor communication between platforms delayed shutting down production on nearby facilities. At 11:18 p.m., a riser from the Claymore platform failed, causing another explosion. The fire and structural damage led to the gradual collapse of the platform. At 12:45 a.m., the accommodation module, where many workers sought refuge, overturned into the sea, marking the final structural failure. Evacuation efforts were chaotic, with blocked escape routes, inaccessible lifeboats, and unmaintained emergency equipment contributing to the high death toll. What are the root causes? Technical failures, poor design of firewalls and insufficient separation between production and living quarters. Emergency systems lacked redundancy and were vulnerable to explosions and fire. Human errors, maintenance missteps, such as improperly sealing the blind flange and failing to communicate the valve's removal. On underqualified personnel during high-risk operations. Emergency failures, lifeboats and evacuation systems were inaccessible or failed, leaving survivors to jump into the sea for rescue. Regulatory lapses, weak enforcement of safety standards and a lack of stringent design requirements for handling severe fire loads. Key lessons and mitigations. Management of change. Ensure safety is central to all design modifications, revisiting worst-case scenarios during retrofitting. Improved safety systems, install automated and redundant fire protection systems, ensuring pumps and alarms function during emergencies. Enhanced communication, strengthen permit-to-work systems, shift handovers, and inter-platform communication protocols. Robust maintenance protocols, strict enforcement of permit-to-work systems to prevent miscommunication and improper assembly of components. Safety training, provide robust training to operators on emergency procedures and ensure leadership is prepared for crisis management. Emergency preparedness, equip platforms with accessible and dispersed lifeboats, regularly inspected safety equipment, and smoke-resistant evacuation routes. Regulatory oversight, enforce stricter safety standards, mandate regular inspections, and promote a safety-first culture across the industry. Thank you for watching.